I think will be one of your guys' favorites after today. It's trig, and it's like the most fun thing you'll ever do in math. It's awesome. Once you get it, I promise, it's everyone's favorite. Even if you don't like math, it's always everyone's favorite, okay? So we'll get there at the end of the week when we start trig. But today is just goofy. Today we use proportions, like last chapter, and then we bring in right triangle. So it's kind of like a nice little mix of what we're going into using what we've already learned, okay? So, here we go. Here we go. Maybe. So this is a regular proportion, right? We did this all last chapter. A over B equals C over D. That's just our proportion. But now we just have special names for the letters. So the number that's in the A and the D position are called the extremes. That's what they're called. And then the B and the C, the numbers in these positions are called the means. And a way you can remember that is when you read the proportion. So I would read it A over B equals C over D. You guys see how B and C were in the middle? And middle starts with M, and so does mean. So your means are in the middle. And also this is the only time we ever talk about them, so if you forget it, that's okay. But we have this geometric mean, and that is when your means are the same. So in a proportion, if your means are the same, we can find the geometric mean. It's kind of like a little formula, just a computation. So let's just kind of see what that would look like. So if I had A over B, what would I write instead of C? B, because I want them to be the same, over D. Okay, let's solve for B. Okay, that's what we want to figure out. So what's B times B? B squared equals A times D. So AD. Okay, how do you undo something squared? Squared. So if you wanted to find the geometric mean, you would take the two numbers they give you, and then take the square root of them. That's what we're doing, okay? So, let's try that with a few numbers here. 5 and 45 is our first one. So if you want to find the geometric mean of 5 and 45, so essentially 5 and 45 are your A and your D. So we're solving for B right now. So I'm going to have x squared equals 5 times 45?
Yeah.
What do we get when we multiply those together? 225? Yep. Yep, and if we take the square root of both sides, we get x equals 15. Let's try another one with 12 and 15 here. What is 12 times 15? 180? Okay. Don't hate me, but this is good practice. We're going to simplify our radicals for this section. Okay? So remember, because if we take the square root of 180, it's a decimal, right? It's not a whole number. It's not a perfect square. So we have to figure out what perfect squares fit evenly into 180. So it's just kind of like guess and check in your calculator. Take like 180 divided by a perfect square. You guys remember what perfect squares are? Like 4, 16, 9, 25, 36. 9 fifths? How many times does 9 go into 180? How many? 20? Okay. What's the square root of 9? Square root of 9. 3, okay. But now can I break down the square root of 20 more? So what perfect square goes into 20? 4. How many times?
1.
Ooh. What? 5, right? What's 20 divided by 4? 5. Okay. Square root of 4 is 2. And then 3 times 2 is 6. So we're going to get 6 root 5. Can I break down the square root of 5 anymore? I promise next year you'll be kind of thankful that we reviewed this a little bit because you'll do this a lot next year. Like all of your answers will be like this, not in decimals. But just because I like decimals, what is this approximately? What's 6 times the square root of 5? 13-ish? 13 point like 2? 13.4? Okay. Okay, this is kind of where we bring in last chapter. So do you guys see we have a big right triangle there, right? EFG is a big right triangle. If I draw in an altitude from my angle that is the right angle to the hypotenuse, do you guys see how FH is an altitude? It forms 3 similar right triangles. I have the big one, right? And then I have this left one and this right one. So that is a property. If we have a right triangle and there's an altitude drawn from the right angle to the hypotenuse, I get 3 similar triangles. So let's write a similarity statement for all 3 of those triangles. Okay. So let's start with the big one. How can I name this triangle? EFG. Okay. Is similar to, let's do the left one. So now we got a match. What matches with E on that green triangle? E. And then what matches with F? So on the big one, it was our right angle, right? So what's my right angle on this one? H. And then G matches with F. Okay. And then I have that red one. So what matches with E on the red one? F? Yep. Okay, then I went to the right angle. So what's my right angle on the red one? H. And then G. So I know that's confusing, but we're going to use those 3 triangles today. And it's hard to separate them, so if it makes it easier in your brain, you can redraw all 3 of those out if that makes it easier to do the math. Okay? Let's talk about something on this picture here. If I look at this big outside right triangle, I have 3 legs, right? I have the hypotenuse. What leg's my hypotenuse in that triangle? EG, right? I'll make sure we all know, right? That's my long leg. Okay. My hypotenuse. What would be my short? The short leg. EF, right? And then my long leg would be FG. So now we're going to use what we used in last chapter, the right proportions to find missing lengths using those 3 sides. Let's see how it goes, okay? Let's see how this works. So the first one's nice and easy. We're finding Y. So we first need to decide what 2 triangles am I going to use? 2 smalls or a small and a big? The 2 small ones, right? I have to use this triangle here and this triangle here. Because if I use the big one, I would get nowhere. So I only know one thing about the long and the hypotenuse. Okay. So now from here, we have to set up a proportion. So if I use this left red triangle, what is 4? The short, long, or hypotenuse. So this is how I want you to organize your work so it's a little easier to understand. So let's put short over, and what's y? Long? Okay, so that's our orders. Now we know how to do it. So now let's write our proportion. So we're going to go short, which is 4, over our long, which is y, is equal to, I got to go back to my short. What's my short on the green one? Y. And what's my long? 12. Okay. And the way you know you did it right, do I have a geometric mean here? My means are the same. Perfect. We're good to go. Now we can just solve. Y squared equals 48. And we're going to simplify our square root here. So you're thinking, what's the biggest square root or perfect square that goes into 48? 16? How many times? 3? Nice job. And if you don't know how your classmates are getting that, you guys, it's literally just guess and check. You type in 48, divide by a perfect square. If it works, awesome. If not, try another one. There's no special formula. It's literally just guess and check. Times square root of 3. What is square root of 16? 4. Can I break down the square root of 3 anymore? Nope. That's it. Okay, give me like, so lost, I got it. Yep, okay. Bear with me. It gets kind of confusing with all 3 triangles in here. Because on our next example, look how many variables we have. We have 3. But we just need to be organized and it will be fine. You just have to stay organized. Okay? Again, if I look at my 3 triangles, I have to be able to write a proportion that uses the same letter twice. Because if I have 2 different variables, I can't solve for a variable, right? I have to get one variable by itself. So I would always check to see if you can find this middle altitude first. Because, look, this left triangle here, and this one on the right uses E. Do you guys see that for both of its sides? Okay. So I can write, what is 6? The short, long, or hypotenuse? And then what's E? Long or hypotenuse? Long, right? So this is what we can write, short over long. So here we go. We said our short leg was 6 over our long leg, E. Now if I jump to my green, follow your key. What's my short leg in the green? E over, what's our long? 24. Again, a good check. Do you guys see how I'm getting E times E? I'm getting a geometric mean today. That's perfect. I'm going to get E squared. 6 times 24. 144. This one's nice because 144 is a perfect square, isn't it? What's E? 12. Now we got E is equal to 12. So, yeah? The which one? You sure could, but today I'm just going to use proportions, but in real life or on your homework, if you want to use Pythagorean theorem, go ahead. But I think for your notes, you should write what I do, and then if you get stuck on like homework or test, you can do whatever works for you. He's right. Do you see how you just have a bunch of right triangles? You can use Pythagorean theorem. Okay, so do you guys see how D and C are outside legs? So I know I have to use the big triangle and one of the small ones. Does that make sense? So if I wanted to find D, I have to use this blue one and the big green one. So what leg is D on the blue triangle? The hypotenuse, okay. And what leg is that on my green triangle? Short. So I know I have to use the hypotenuse and the short on this one. Does everyone understand why I have to use those? Because that's what they match on those two different triangles. Okay? So we're going to write short over hypotenuse. Okay, what is my short on the blue triangle? 6, right? And we just said our hypotenuse is D is equal to, now what is our short on the green triangle? D. Perfect. And our hypotenuse is?
30.
Yep. Right, we got to add these two to get 30. Again, you know you're in the clear when you get those geometric means the same. The means are the same. D squared equals 180. We already know what that one simplifies to. What did we get before? 6 we're at 5, I believe, right? That was nice. And then to find C, I have to use the right red triangle and the big one. So what is C on the red triangle? Hypotenuse. And what is it on the green triangle? Long. So I know I have to use hypotenuse over long. Did you do long? Yep, I just want to show you that it could work out this way too, but yes, you sure could. Okay, what is our hypotenuse on the red triangle? C. And what's our long side on the red triangle? Yep. Okay, what's our hypotenuse on the green one? The big triangle? 30. And our long leg is C. So do you see how it ended up in the extreme spot? But the math will still work out. So I just wanted to show you that it's okay if you flip-flop those. All right. C squared equals 720. And we got to break that guy down. I'll tell you it's between 11 and 16. So like try 11 squared, so like 121 or 225. Couldn't you do more? Just 144 fit evenly into there? How many times? 5? What's the square root of 144? 12. Can we break down square root of 5? No. Guys, I know this is confusing and kind of all over the place. Start the next one, see how far you get before you get stuck. Talk it out with people around you. Start by finding x. That's the easiest one. And it won't look exactly the same as what we just did. Like, label your word. You'll use the two small triangles on the find x. I know this is a good picture on that one. And it's okay if you have no idea. I mean, we're learning, right? It's fine if you have no idea. Well, that's how we learn. This one works out nice. You should get whole numbers for all three variables. And you did x equals 16?
I did.
You of us? Okay, good start. Okay, I found y next when I did it. I don't know if that helps you. I didn't find y maybe. So if you have a hard time figuring out how to write your proportion on y, you gotta think, on this left little triangle, what leg is y? Short, long, or hypotenuse? Hypotenuse. I know I have to use the hypotenuse, and then you gotta look on the big picture, what leg is y on the big triangle? The long side. So now when you write your proportion, you have to use the hypotenuse and the long. So our long side is, oops. get 20 on their own? Y equals 20?
I did the Pythagorean theorem, but I got
That's okay. At the end of the day, it's how you get the answer that matters, not anything else. Okay, on Z, on the right triangle, what leg is Z? On the little right triangle?
hypotenuse.
Hypotenuse. And then on the big outside triangle, what leg is it? Short. Now we just write it out. So I have Z. What's my short leg on my little right triangle? 9. Then our hypotenuse. And the big one is 25 over Z. Z squared equals, oh my goodness, 2. Z is, I almost wish they would have put this section in our last chapter because this gives you a bad taste of what's to come, but just know it gets way better after today, okay? It gets way better.